Hey guys, welcome back to my YouTube channel. So here we are going to start a new chapter, that is combinational circuit. So combinational circuit is nothing but whenever what are the mathematical or what are the normal logical functions that we are doing. So we will be implementing that with the logic functions or gate. So that is what the importance of combinational circuit. So let me first start with an off adder. So off adder is one of the important topic that we can start. So this is the fundamental foundation for everything. So in college days, we usually do practicals also, right? In off adder, we will be implementing that with XR gate, everything. So here, let's see how we can do that. So off adder is that how we normally adding, right? So after adding, for an example, if 0 we add, output will be 0 and no carry. So 0 1 is added, output will be 1. If 1 0 is added, output will be 1, and 1 1 is added, output is 0 and carry is 1, right? So this is how. So here if you see the C in is 0 but C out is 0. So there is an overflow. So this is what the overflow. I am lastly stated the term, right? So this is what the overflow. So here, so this will be, so this the output can be here can be represented in a logical diagram. So that is what the thing that we are going to do here. So let me first start with the off adder. So let me build a truth table for off adder. So it will be very simple, normal logical things, and you guys can enjoy these kind of lectures. So in sequential circuits only, we need to do some more mathematics there. So here you can chill and enjoy. So A, B, sum and carry. So we are going to mention. So it's a 2 input of as it is half adder. So if it full adder, that we consider for 3 bit. So 1 0 1 0 1 1. So if you add 0 0, we know sum is 0 and carry is 0. So if you add 1, sum is 1, carry is 0. If you add 1 0, sum is 1, carry is 0. Right? So if you add 1 1, sum is 0 and carry is 1. Okay. So we are going to find the logic for this one. So here what you can do, even you can use the k maps, right? So you can use k map and find out the logic. But for yes, in order to find out the yes, we know that is the 1 is present when the input is different. So that is an XOR logic. So we are directly going to mention that is A XOR B. So CY, the carry function can also be known, that is an AND function. So all things are 0. So this is AB. So we have find out this directly. Okay. So even we can represent it in a logical circuit. How we can represent is this is the two input A and B. Okay, let's take this as A and this as B. So what we can do, we can take this output like let me do it properly. So we can take this output a jumper and then this B. So both can be connected to an XOR. So XOR, right? So both can be connected to XOR. Okay. So here it will be the summation value. If we give both to AND gate, so then this will be a carry. So this is an AND gate. So this is carry CY. Okay. So this is how we can implement. So here you see the mathematical thing that we done here now will be done by these two gates. So this is the logical representation or logical diagram that we can do here. So this is the truth table of this. So even we can represent this as a black box. So some people will in EC engineer, everything we will be mentioning mostly in a black box, right? So similar to that. So even we can mention this as a black box. The thing is that there is a two input A and B and there will be two output, that is sum and carry out. So this box is called as off adder. So if we give two input, then it will take care. This circuit will lie inside. So that is we need to understand. So this is what the black box concept that we use in our EC subjects. Okay. So now let's take a full adder. So extending this to full adder. So we will be adding 3 bits full adder. So that's what the quite different here. So we will be adding 3 bits. So that 3 bits mean nothing much difference. So we just include another one, that is a C in. So which is nothing but a carry from the previous thing, not from this current one. So we will consider the carry, because in this case there was no carry in any of the thing, only at the last thing there was carry. So that thing we can skip it. But in the previous case, if a carry comes here, then that the system can't handle this one. So in order to make that, we are going to full adder. So let's see how the full adder works. So let me directly go to the truth table. So which is A, which is B, which is C, sum and carry. Okay. So as it is 3 bit, this is C in because it is carry from previous thing. So 0 0 0, so 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay, extend it. So if we add this one, then sum will be 0, carry will be 0. If we add sum will be 1, carry will be 0. Sum will be 1, carry will be 0. So in this case, the sum will be 0, carry will be 1. So in this case, sum will be 1, carry will be 0. Right? Here the sum will be 0 and carry will be 1. Sum will be 0, carry will be 1. Here sum is 1, carry is also 1. Okay. I hope you're able to understand this, right? So this is normal. So if it is 1 1 1 is there. So this is 3. So 3 we can be written as 1 1. So that's what we have made here. Okay. So I hope this is understood. So let me draw a functional thing. So yes. So S is a function summation of min term. So which is nothing but 1, 2, 4 and 7. Right. So 1, 2, 4, 7. So I am suggesting you guys to go to K-map and find the thing. So I am directly writing the logic. So here you can directly go and find out the logic. So if it is comes like this, so if you guys mention in a K-map, that will be something quite different. So even for that, you can remember the thing that when 1, 2, 4, 1 are the min term output, then the output will be the XOR of all the 3 inputs. Okay, so this is what the output. The carry Cout summation function can be written as, here it is 3, 5, 6 and 7, right? So 3, 5, 6, 7. So I am also suggesting this to go on represent K-map and find out the min term. So I am directly writing this A plus B, B plus C plus CA. Okay, these are all the things. So even this can be simplified with XOR, that is A XOR B, C plus AB. So these two terms, anything you can use it. Okay, so I hope you guys are able to understand this, right? So even you guys can represent this in a the diagrammatic way of thing, or even you can use a full adder like a black box or anything. So I am going to create a full adder with the help of half adder. So let me do that. So I'm going to do full adder using half adder. So these kind of questions can be asked in gate. So full adder using an half adder. So let me do it in a black box style. It's simple, not that much difficult. So let me take two half adders. Okay, so let's skip it. So here we are giving two input, A and B. So this is an half adder. So we know that the output here S will be A XOR B. So here output CY will be AB, right? So here we are taking another one half adder and we are creating a new input here. So we need a output, the summation, this one will be A XOR B XOR C. So what we can do, this will do XOR of this and this. So just simply connect this two. So simply connect this two. So here the carry here which is need to be two things, AB plus BC plus CA, or another one term is there, right, with XOR A XOR B C plus AB. So both things we need. So we know that this one can do the multiplication of this one. So I'm just erasing to represent that one. So the end result is that, but for now what we will get here is that the summation of both the two, sorry, multiplication AND of these both the two. So this will be equal to A XOR B into C. So this only we get. So sum we already get it, but the carry we need to get. So we know the carry formula that we need to add A B to this. So this one we already got it. So this is dot of AB. So we need to just add this to it. So let's take this one and give to OR gate, and we will be getting the overall carry. So which is what this. So this will be equal to, so this is not a carry actually. So we need to erase it. So this is one. So this is half order carry only. So this is also not a carry, but we can represent it as a carry for half adder. So let me write here. So this is what our end result, that is A XOR B the C plus AB. So I hope you guys know how we can do a full adder with the help of half adders. So what are the things required is a two half adder we need plus one OR gate. So this is the requirement. If they ask in the question what are the requirement to make full adder with the help of half adder, so please make use of it. So I hope this is understood. So I am leaving here. So in the next class, let's start with the half adder, half subtractor and full subtractor. So I hope today's lecture is quite easy. So we have built an half adder and then same for full adder. So this is normal thing. So one homework that what you guys can do is that please go to K-map and write. So if we represent it in a K-map, so that how it will look like is this one. So how it will look like is this one. So like how we are mentioning here, right? Okay, so this is, let's take randomly as A, B and C. Oh, this is the 3 input gate. I wrongly wrote it. Okay, no problem. Let me erase it. Okay, so let's take this one. So this is A, this is BC. So if you know 0 1 0 0 0 1 1 1 1 0. So if we note all the term, that is 1 2 3 4 5 6 7. Here you see we can't map any of the grouping, so none of the group will combine here. So the thing is that we have to take everything singly. So this is separately, this is separately, this is separately, and this is separately. So here no logic can be written here. So this is one of the quite thing that you have to remember, or even you can solve it. So even if we do this, even with using the k-map, we can't able to get the required reduced term. So, but one thing what we can do is that we can remember whenever these kind of distinct logics come, then we can do this kind of understanding that this will be in XR. So this is one of the thing you guys can note it or remember, because it will simplify your calculations, right? Because instead of going over everything, so we can simply directly write whenever there is an output logic which is comes like this, then we can directly represent that with this. So this is with XR. So XNOR also has one different combination, so that I am also mentioning here. So this is XNOR, this is for XR. The same thing will come for XR. So I am representing that in another one table. So let me, how XNOR will be there is there the similar thing, but it is quite opposite. So A, B, C, 0 1 0 0 0 1 1 1 1 0. Here it is like this one, like if you see that is a upward slope, here it will be reverse like, so 1 1 1 1. So this is for XOR, so this is for this one. So here it will be XNOR, A XOR B XNOR C. So this is how the logic will be. So this is not completely XOR, so one XOR and one XNOR. So that is what the thing will come for this one. So this term in term representation is summation of M 0 comma 3 comma 5 comma 6. So this term in term is 1 2 4 7. So please make note of it. So this is this, even for 4 input the same thing. So here you plus add the two boxes. So add two boxes and make a note of say 1 1 1 1. So this will be for 4 input XOR. So then repeat this 1 1 1 1. So this is for 4 input the same thing. So I hope you guys able to, this is, so there is one another term that you have to note. So if this is repeated for another one thing, for 4 input this will come as a XOR, complete XOR, XNOR. This is C, C. This is only for 4 input. So this is for 3 input. Okay, I hope you guys able to understand it, right? So if it is comes in 4, so like this one, if it is repeated like this one, so if it is comes like this, then this is 4 input XNOR. Here it is 4 input XNOR, both same. For 3 and 4 it is same, that is XR. That is XR, that is same. So there is no problem. But in this case, 3 input, one will have one XR, another one have XNOR. But in 4 input, we have all thing as a XNOR. So that is one thing you have to remember. Even this can be interchangeable. So even we can write the 3 input thing like this one also. So this can even be written like this one, like A XR B XNOR C. So like this way also we can write. There is no problem in this. So please make a note of it. For 4 input this is, for 3 input this one. Here whatever may be the input, that is XR only. So if there is anything, any kind of indirect things comes, please make use of this one and don't rely on everything, so that you guys can save some time in the things. So I hope you guys got the thing. So if you guys haven't understood it, please ask again or post in the comment section. I will for sure rectify it. Thank you. Stay tuned, guys.